So, good afternoon. My name is Daniel. I am a computer engineer, and on this project, I was in charge of the web app portion.
My name is Adam Jennings. I'm a computer engineer. My portion of the project was focusing on the faucet controller.
Good afternoon. My name is Alex Espinoza. My portion of the project is focusing on the microcontroller aspect of the project.
My name is Yufeng. My major is computer engineering. I'm focusing on the voice controller.
Hello, my name is Aditya Narayan, and I'm a computer engineer, and my focus is also to help Adam with the faucet controller.
And we are the members that make up Symbiotech, which is our team. As you notice, smart technology is very prevalent nowadays. Most of these presentations were involving smart technology in some way. So our team decided to dive headfirst into smart technology and tackle one of the many things in there. We decided to do smart water faucet systems. Upon initial research, we found there are solutions available. However, we don't find that they're either too high of a price for what they offer, or they don't offer enough features. And so our solution is to offer more features at a lower price. What we have developed here, we have a central controller that will go into your home and will be a central hub for all of your connected devices. At each faucet, we'll have a faucet controller that will also have connected servers and motors and things in order to physically control the faucet to allow you to have a specific volume of water you want or a temperature. Also, with the smart technology, be able to schedule a time that you say you want a shower to start or something like that. We also have, of course, a web app that is connected with a cloud database. All the faucet controllers will be collecting data from your faucets for volume and temperature and things like that, so you can help monitor that. All of that data will be made available to the user through the web app, through your phone. Be usable inside your home or outside your home if you're connected to that network or not, through that web app. For the central controller, we've decided on a Raspberry Pi 4, and the faucet controller, we've decided on an Arduino Duo clone just to help with cost. And that is really all there is to say about that project. So, any questions?
Cost estimates yet?
Sure. Initial cost estimates we've done, doing a kitchen faucet, a bathroom faucet, a shower, or standalone shower, and a bathtub faucet are just under $900 for the whole system.
That includes valves?
That includes valves and everything.
So it's not clear to me what is the main problem that's being solved. Like, why would I want to turn on a faucet somewhere else in the house from where I'm standing now?
Some of the problems we looked at trying to resolve with this system, first one being my biggest problem is waking up in the morning when it's 30 degrees outside like the past few days and having to get in the shower. I could easily lay in my bed and say, Alexa, start shower for Adam. The shower would go ahead, start, get to my predetermined temperature, shut off, notify me that it's ready so that I can jump in the shower and not have to wait for it to warm up. Also, if you're a mother in the kitchen, you're cooking, and you're wanting to dispense exactly 2 cups of water, you're trying to hold a 2-year-old child in your hand while trying to measure water. I can put that in the sink and say, Alexa, kitchen faucet, 1 cup of water. It'll dispense exactly 1 cup of water for me to cook with. So those are just a few of the problems.
So just comment that those use cases help. Put something like that in your slide would be useful.
Sure.
Well, what's the communication between the central controller and the faucet controller?
Right now we're looking at Wi-Fi communication, so just to have them so that they can reach relatively easily across the house and have them just communicate. It's constantly sending each other data whenever needed and commands as well through there.
So, since you're going to be controlling a water faucet in the house, I can easily see something like the bathtub filling up and overflowing if there's a failure. So what steps are you taking in the hardware design to make sure that if there's a failure in the controller that it doesn't just leave the water running?
I mean, most bathtubs have the, I don't know the technical term for it, I call it the overflow drain that usually sits at the top to keep it from overfilling. But you'd be able to preset a size of bathtub in the controller, and it would be able to measure the output of water and turn off on its own before it hits that limit.
Yeah, we're assuming that there's a failure in the software, it hangs, anything that goes wrong with that MCU while the valve has been turned open results in a flooding event. So I would strongly encourage you to think about kind of the safety and what can go wrong and what the appropriate response to that is
Sure.
with your hardware. Not just does the software have a routine to handle it, but make sure that even if it doesn't work, that you won't have an unfortunate event, shall we say.
Sure.
What's the spatial range you intend to cover?
It should be approximately like within a 20 feet like radius, so that's inside like the house. That's what we intended to cover.
So this wouldn't be sufficient to cover a lawn sprinkling?
That would be sufficient, yeah, especially like through your back, from the front yard to your, from the front porch to your backyard.
Say, would or would not?
It would.
Well,
So 20 feet is the range?
20 feet is the range.
Okay, well, that's not gonna work. If I'm sitting in bed, I'm not gonna be able to send a signal to the kitchen from where I am.
So if you're out of the range, you can actually get multiple central controllers. So you can place another central controller in like the 25 mark. Then from 25 to 40 you get reception.
So it's like an extender?
Yeah.
All right, let's thank the